capital A11 is the cofactor of first row, first column element is equals, right? So how much we get deleting row and column using the sign as well. We get 2 3s are 6, minus 3, that will be 3, right? So like I deleted row 1 and I deleted column 1, then I should find determinant of 2, minus 3, minus 1 and 3. 2 3s are 6, minus 3, that is 6 only. Similarly, A1 2, first row, second column, deleting it, 1 minus 3, 2 and 3. So we have 3 plus 6. 3 plus 6 is 9. Since the sign for this is negative, we are writing minus 9. Am I clear in this? I'm directly writing like from the sign matrix plus, minus, plus, minus, plus and minus, plus, minus, plus. Using the signs for the now A13, deleting the corresponding row 1 and corresponding column 3. After deleting, we have minus 5 as the determinant. We need to multiply with plus only in this case. So we will be having minus 5 here. So row 1, 10. Now row 2, if I am taking A21, deleting second row and first column, we have 3 plus 1, 4 as the determinant value. Minor value, we need to multiply minus 1 to this. So minus 1 into, one moment, 1, what we are deleting, second row and first column. Okay, 1, 3 plus 1, 4. Minus 4. So A22. So we have deleting second row and second column. 3 minus 2, 1 we will get. A23. So deleting second row and third column. Using minus, we have minus 1 and minus 2, which will be equals to 3. A31. A31 will be minus 5. A32 will be minus of minus 4. A33 is 2 minus 1, which is 1. So cofactor matrix of A we have with us. Cofactor matrix of A will be, so like 3, minus 9, minus 5, minus 4, 1 and 3, minus 5, 4 and 1. Transpose of cofactor matrix is adjoint matrix. So taking transpose on both sides. Adjoint of A is equals to 3 minus 4 minus 5 minus 9 1 4 minus 5 3 and 1. This is the transpose of cofactor matrix. So option, which option we are getting? Second option. They have given second only, no? Okay, then like now the shortcut one. Please do listen. Right. Yesterday I think I have given the glimpse. If you didn't learn in school, it might help you to verify whether you got correct or not. Only if you are calculating properly. Right. So in this shortcut, what we need to do is we need to write the same matrix, given matrix 4 times. Right. The given matrix, let me write 4 times. It is 1, 1 and 1. Next is 1, 2, minus 3. After this, it will be 2, -1 and 3. So once I wrote a second time again 1 and then 1. 1, 2, -3, 2, -1, 3. So like again below also 2 times we are writing 1, 1, 1. 1, 2, -3, 2, -1, 3. 1, 1 and 1. 1, 2, -3, 2, -1, 3. So like once you wrote the matrix 4 times, 1, 2, 3, 4. Like remove the extreme row and extreme column. Like we are striking out. This is the starting row and ending row. So like again remove the starting column and ending column. Once you remove this, listen to me carefully. Like here, to get the elements in row, please move in vertical direction. To get the elements in column, please move in horizontal direction. Let's say I'm writing, listen carefully. Adjoint of A is equals to. I'm not sure, like I'm moving that one little above, so that like no idea at all. What we will do is like starting 4 elements we'll take. Starting 4, this 4, no need to put any sign. It is -1, I guess. -1 went. No need to put any sign. Just take this 4, find the determinant. This is first row, first column element in the adjoint. Next, exclude it, take the 4. This is first row, second column element, determinant, and then exclude it again. First row, third column element. Row 1 is done, na? Then, like again, hide this one. These two you consider, and then again, take this 4, second row, first column element. And then, like this 4, second row, second column, and so on. Right? Starting with this, 2 3s are 6, right? Determinant we are finding 2 3s are 6 minus -1 into -3. 6 minus 3 will be equals to +3. In the same way, these two you consider and these two. -1 into 1 is -1 and -3 we have -4. Clear? And then like again, same thing. This is -3 and this will be -2. We have -5. No need to worry about any sign, anything here. Clear? Understood? Any doubts in this? Anybody? So like next. Row 1 you finished, you can do either row wise or column wise. As I mentioned, row wise I am moving, so in this direction I am moving top to bottom, vertical direction. If I want to write columns, I'll move left to right, horizontal direction. Clear? So like once row 1 is done, row 2 we are considering. For row 2 again, consider these 4 elements. Clear? Understood that 4 elements, find the determinants. It is -6 -3, you will get -9. And then again, these two, 3 -2, you will be having 1. And then like here, 1 minus of minus plus 3 is 4. Right? So same thing next, we will be having -1 and -4, that will be equals to -5. 2 plus 1 seems 3. 2 minus 1 seems 1. Do we got same answer? Yes, we do got same answer. Like again, write the given matrix 4 times. 1, 2, 3, 4. Like square is there in that 4 different blocks. We are filling with the matrices. Strike out the topmost row and then bottommost row and then leftmost column, rightmost column, and then like take 2 at a time. Either rows or columns. Take 2 at a time, find determinant and write the adjoint. Am I clear? First is like these two, like if I give the names, this is row 1 and row 2 you consider. And then for row 1 elements, row 2 and row 3 in this way and 4 as well. Any doubts in this? Anybody? Any doubts in this? This is how we will find adjoint in shortcut. So like I don't know what is the shortcut name. This one thought by Rakesh. I named this one as Rakesh method. That student name is Rakesh. He only told me. He learned from YouTube or from his teacher, it seems. So I'll call Rakesh method. Am I clear? So he's my last year student. Unfortunately, he was not able to crack JE. I think he's in VAT. Right? Can I scroll up? Anybody writing any part of the solution? No, right? So like next to the adjoint and cofactors, we need to learn about few things, few note points, not exactly the properties. We are writing them one by one. See, I didn't give the proper definition of a determinant earlier. So like here we can write the proper definition of a determinant. See, like the definition of a determinant using cofactors, we'll say the sum of the product of the elements of any row or column with the corresponding cofactors is called the determinant. Am I clear? So like we can see that maybe if we are taking an order 3 matrix, so delta A1, A2, A3, maybe A11 in this way only we'll write. A12, A13, A21, A22, A23. So A31, A32, A33. So this is the determinant actually. Like normally we are expanding using row 1. Let us say what we write. We write A11 into determinant of A22, A23, A32, A33 minus A12 into determinant of A21, A23, A31, A33 plus A13 into determinant of A21, A22, A31, A32. So like what we can say here, listen, this first determinant is there, no? This first determinant I can call as cofactor of the element A11. See like including the minus one, minus you multiply here, you can say A12 into the second one is cofactor for the A12. Clear? And the last one is cofactor for the A13. This value is equals to A11 into capital A11 plus A12 into capital A12 plus A13 into capital A13. This is what the actual definition of a determinant. The sum of the product of the elements of any row with corresponding cofactors. What happens if I multiply the elements of row 1 and cofactors of row 2? Anybody knows? If you studied in school? 0. Yes, good. Like if you are multiplying like elements of row 1 with the corresponding cofactors of row 2, you will get 0 there. We can prove that. Maybe like for proving I'll take second order one, that is easier to do. That's only I'm taking. Anybody, any doubts in this? Can I scroll up? Scrolling up. Second one. The sum of the product of the elements of any row or column with the corresponding cofactors of any other row or column will be equals to 0. We can say that if we are taking order 3 matrix, for example, we are writing A11 into A21 plus A12 into A22, A13 into A23 must be equals to 0. So to see this result, we are considering a second order square matrix. So like here, capital A, B, C, D. So A11 is equals to A12 is equals to B. Now, cofactor of A11, maybe A21 I need here. A21 will be equals to, how much we'll get? We'll get minus B. Cofactor of A22, it will be equals to A. Right, I hope you understood. I directly wrote. I have taken A, B, C, D as a small matrix. So like A11 and A12 is A and B respectively. Cofactor of second row first column element will be equals to -1 into delete the row and column. So A22 is like delete the row and column. This one. Sign also I am using here. Now like if I do here A11 into A21 plus A12 into A22. This will be equals to A into minus B plus B into A. This one we can clearly see that is equals to 0. It is an important property for cofactors. Clear? Any doubt in this? Anybody? Scroll up. Okay, va? This is the second property. Now let me ask. Let us say I have a diagonal matrix. I think that is simple one. Let us make it little difficult. If I have a upper triangular matrix, can you tell me the cofactor matrix of any upper triangular matrix will be what? If a matrix is upper triangular, then what will be the cofactor matrix of upper triangular matrix? Cofactor matrix of upper triangular matrix, you will get as lower triangular matrix. You do the transpose, you will get again upper triangular matrix. Normally, if you can think I'm talking to you, take any upper triangular matrix, do transpose, you will get lower triangular. Clear? So like here actually we write as a note points. There we will write like whatever matrix you are taking, their adjoint will be the same one. Clear? So like we can start with the basic thing what we learned. Like we have learned initially rectangle and all keep aside. I think starting thing we started with upper triangle. Adjoint of an upper triangular matrix is upper triangular. Adjoint of a lower triangular is lower triangular. Diagonal matrix is diagonal. Clear? We can write here, it is easier for a diagonal matrix to find the adjoint. Can I scroll up? All done? Here, all done. So like the third one, I'll just dictate, please write for me. Adjoint of a upper triangular matrix is upper triangular matrix. You want me to repeat again, Mithun? Adjoint of any triangular matrix is triangular matrix. Anything is same. First I said adjoint of a upper triangular matrix is upper triangular matrix. Next I said adjoint of a triangular matrix is triangular matrix. Clear? That is third one. Like in simple terms, if A is triangular, then adjoint of A is also triangular. Adjoint of a diagonal matrix is a diagonal matrix. If A is diagonal matrix, an adjoint of A is also diagonal. About symmetric and skew symmetric, we'll write when we finish the properties. Right? What extra we learned? Maybe for example, in diagonal you can add this. If A is equals to DIA, D1, D2, D3. It is an order 3 diagonal matrix. DIA stands for just principal diagonal. Then adjoint of A must be equals to DIA, D2, D3, D1, D3, D1, D2. Very simple, like only diagonal elements will be there. Deleting row and column, finding the determinant product between D2 and D3, and so on. Clear? Any doubts in this? Like you can add adjoint of a identity matrix is identity matrix. Adjoint of a null matrix is null matrix. Am I clear? Any doubt in this? Anybody? Any doubts? Add that 2 as well. See, like if adjoint you are getting as upper triangular matrix, please keep this one in mind. Cofactor will be a lower triangular matrix. Do the transpose, then only you will get. Clear? Right. So any type I forgot, I will tell about symmetric and skew symmetric in properties. Anything else? In types of matrices, if you remember anything we didn't covered. Here, I think we did everything. So next we are going into properties of a adjoint matrix. These are all important things they asked in JEE mains, based on like different things. I think 1 and 2 we already covered earlier. Property number 1, adjoint of an identity matrix is equals to identity matrix. IN stands for identity matrix of order n. Clear? So like adjoint of a null matrix is null matrix. ON is a null matrix of order n cross n, square null matrix. Right? So the third one, this is like for any square matrix A, we wrote A into adjoint A is equals adjoint A into A is equals determinant of A into identity matrix of order n. We can prove this by taking second order square matrix. That will be easier. If we take third order, it will be little lengthier. This is a theorem you can write. Like here, a matrix and its adjoint matrix is always commutative. If you want, you can add this here. Like now in this proof, let us consider A is equals to matrix A, second order we are considering small a, small b, small c, and small d. So, yesterday I thought how to find adjoint of a second order square matrix. Interchange the principal diagonal elements, multiply -1 to the non-principal diagonal elements. This is adjoint A. So here, next we are finding A into adjoint of A. This must be equals to A, B, C, D. We are multiplying with D minus B minus C into A. So like sidewise we keep a determinant of A value as well. AD minus BC. Right? So in multiplication of matrices, we can say we are doing dot product between row vectors with the column vectors. Row 1 dot column 1, if we are doing this is AD minus BC. Row 1 dot column 2, if you are doing this is minus AB plus AB. Row 2 dot column 1, if we are doing this is AD, oh sorry, not AD, this is CD minus CD. Row 2 dot with column 2, if we do it is minus BC plus AD. We can observe that first row, this element and this element is 0 getting cancelled, plus AB minus AB plus CD minus CD. Next we can write this will be equals to AD minus BC 0, and this is 0. This is also AD minus BC. Like AD minus BC is the value of determinant. We can take like in a matrix, if we are taking anything out, we should take from each and every element. It is not like determinant. We are taking AD minus DC out. If we are taking, this will be equals to AD minus BC. Remaining is 1, 0, 0. Clear? So like this implies we can write A into adjoint A is equals adjoint A into A, that will be equals to determinant of A into identity matrix of order 2 we proved here. Clear? Any doubt in any part of this one? This is an important theorem. From here only we will find the inverse of the matrix. Can I scroll up? Anybody writing this part of the slide? No, right? Scrolling up then. Can you call them? What you guys are doing? Solving only, no? Not using phone, right? Fully I can scroll up. So then this is the next property. Property number. Number might be different, right? Whatever you want to write. In this, we told determinant of adjoint of a matrix A must be equals determinant of A to the power n minus 1, where n is the order of a matrix. Clear? Right? So like how to prove this one? Not difficult. Like we know that we have learnt this theorem earlier. Matrix into adjoint of A is equals determinant of A into identity matrix of order n. taking debt on both sides. Debt on both sides means determinant on both sides. Now this becomes determinant of A into adjoint of A is equals determinant of A into identity matrix of order n. Left hand side, I have product between two matrices. We know that determinant of x into y is equals determinant of x into determinant of y. Like when you have product, determinant is distributive. That's what I am saying. This is determinant of A into determinant of adjoint of A is equals. Right? So one property I used, what is that? Since determinant of x into y is equals determinant of x into determinant of y. Right? Second thing, like if there is any scalar inside a determinant, if we are taking that out, determinant of k into matrix A must be equals determinant of, k power n into determinant of A. This is the second property I will use here. Like determinant of A is a scalar quantity, not a matrix. If I am taking out, I should write det A power n into determinant of identity matrix. I am cancelling determinant of A on both sides. One determinant of A got cancelled, and I can write determinant of adjoint of A is equals determinant of A to the power n minus 1. I hope I am clear in this, where n is the order of a matrix. Right? In determinant is 1. Like if you want, you can add this special case next to this. In our 12th grade JEE mains, most of the times they have given second order. If n is equals to 2, then we can write here determinant of adjoint of A is nothing but determinant of A itself. For a second order matrix, determinant of adjoint A is determinant of A. So like now, if n is equals to 3, then determinant of adjoint of A is equals to determinant of A square. There's a special case, we can say n value. So like after copying this property, problem number 45, I'll solve here. If you want, you can also give one try. Meanwhile, if you have books, you see in the books. For my reference and for those who don't have book, I kept here. You don't have book? Please make sure there is, give the book back. That is ma'am's book, not mine. 45. It is an application of this property. That's why I kept next to this property. Can I scroll up? Can I scroll up? Anybody writing this part? No, right? Dear online students, are you following me?
Yes, sir.
Okay, thank you for responding. This is problem 45. In problem 45, read all the given information. So like in this problem, they have given set S. Inside set S, we have square root of n such that 1 less than or equals n less than or equals 50 and n is a order. So like next to this, I can write that S is equals to n, like only square roots of odd numbers we have. That will be root 1, root 3, root 5, and so on. Root 49. If you want, you can write as 7. I'm writing as root 49. Clear? So now they have given A belongs to S and matrix A is equals to 1 0 A minus 1 1 0 minus A and 0 1. This is matrix A. Now, summation of A belongs to S, det of adjoint of A is equals 100 into lambda. So like what I can say, this entire problem first of all depending on this value, det of adjoint of A. For an order 3 matrix, we know that what we know. For 3 cross 3 matrix, det of adjoint of A is equals determinant of A whole square. Can you guys tell me how much is determinant for this matrix? A? Correct only, yeah? Determinant of A is equals to 1 into, okay, we have A square plus 1. So next we can write, one moment. Maybe I'm leaving this space. I'll go above. Give me a moment, please. So like I can write now det of adjoint of A is equals determinant of A whole square, that is A square plus 1 whole square. A square plus 1, maybe we'll keep like this. The expanding might be trickier. Let us substitute here summation A belongs to S, det of A square plus 1 whole square is equals 100 into lambda. We need to find that lambda, right? So A is from set A, set S. A can be root 1. One moment, one moment. No, like 1 moment. A square plus 1 whole square. Now it is perfect, I guess. Right? So left hand side, this is 100 lambda is equals right hand side. The values of A is from set S. A can be root 1, A can be root 3, A can be root 5 and so on. A can be root 49. Right? If A is that values, we need A square. A square is 1, 3, 5 and so on 49. We are substituting one by one. We will get like how much we'll get if I substitute A is equals to root 1. A square becomes 1. 1 plus 1 is 2. We have 2 square. Am I clear? Understanding this one? Any doubt in this? First I substituted A is equals to root 1. If I substitute A is equals to a root 3. How much I'll get? Here if I substitute a root 3 whole square is 3. 3 plus 1 is 4. 4 square we have in this. Next you will get 6 square, 8 square and so on. We are going till 50 square. If you want you can substitute A is equals to root 49. It is 49 plus 1, right? 49 plus 1 is 50. Square you do 50 square. Right? So like next we can say this is 100 into lambda is equals. What we can do here? We can take this is 2 square, 4 square, 6 square, everything is even number squares. From everything I can take one 4 common, right? One 2 square common. If I take one 2 square common, this is 2 square into 1 will be there, that we write 1 square. Now 4 square is 16. From 16 we have taken 4 out. Remaining is 4, that we'll write as 2 square. Now 6 square is 36. From 36 we have taken 4. Right? Remaining is 9. 9 means 3 square. And so on. Last you will be having is 25 square. Right? Understood? Any doubt in this? Next, like both sides you cancel 4. 25 lambda is equals sum of squares of first 25 natural number. This is 25 into 26 into, and we have 51 divided by 6. 25 got cancelled. Lambda is equals 2 3s are 2 17s are 3 1s are 3 17s are. I have 17 into 17. 17 into 17 is 2. One moment. Mistake. This is 13. Calculation mistake I did. Sorry. 13 into 17. 220. Clear? Any doubt in any part? Please copy this. Copied. Let us move to the next property. Any doubts? Online, offline? No doubts, right? So like this is next property number you only keep. So like adjoint of a scalar into matrix A will be equals to. Dear
Sir,
online.
Sir, can you
Sorry?
scroll up?
Some doubt?
No, sir. Can you scroll up little bit?
Is this okay?
Okay. Okay, sir.
Or this one also you want to copy?
Okay, sir. Scroll down, sir.
So like you guys can write this statement meanwhile. Are we done? So like this is next one. Not difficult, but little different. This one. Adjoint of a scalar into matrix A. Like again, everything I'll do the proof from the basic. We know that a matrix into adjoint matrix is equals determinant of A into identity matrix. This is the important theorem for adjoint. Now, in this, let us replace matrix A with K into A. If we do that, we have K into matrix A into adjoint of Ka is equals determinant of Ka into identity matrix. Right? So like now pre-multiply, pre means in the beginning. With adjoint A on both sides. If we pre-multiply with adjoint A on both sides, listen, it is a scalar can be taken out. We are doing that. This is K into adjoint of A into matrix A into adjoint of Ka. This is equals to determinant of K into matrix A into adjoint A we will get, because like multiplication with identity, you do any matrix, you will do that matrix. Next, I am taking the scalar out of the determinant. If I take the scalar out of the determinant, I should write K power n. And then I am using the associative property of matrices. And this is X, Y, Z. I can write X into Y. Doing that, this is scalar into adjoint of A into matrix A into adjoint of Ka. This must be equals K power n into determinant of A into adjoint of A. If you observe this bracket from the property number 1, adjoint A into matrix A is determinant of A into identity. Identity anyway you will multiply, just determinant A you will be having. K into determinant of matrix A into adjoint of Ka is equals K power n determinant of A adjoint of A. Both sides cancel one K, cancel determinant A, adjoint of K into A is equals K to the power n minus 1 into adjoint of A. Any doubts? See, like for this one, left hand side, left multiply also we can write. Pre-na in the beginning, post means at the ending. We are multiplying with adjoint of A, right? So both sides here identity into adjoint A, you will be having adjoint A. This one is clear. Next, what I am doing, like this is X into YZ. Matrix multiplication is associative. I wrote XY into Z. Clear? And then like there, here I have taken out. Using the theorem, adjoint A into A must be equals determinant A into identity. I didn't wrote. Next, I am cancelling one K, one determinant A on both. Clear? Understood? Now, like special case, we can write here. If n is equals to 2, then adjoint of Ka is equals K into adjoint A. If n is equals to 3, then adjoint of Ka will be equals to K square into adjoint A. Right? So next you can, I hope everybody copied. You can copy the next property as well. This is for determinant of the above matrix. Determinant of above thing I have taken. Determinant of adjoint of K into matrix A, where K is a scalar. Can I scroll up? So like proving part, you can do by yourself. What you need to do is like use the previous result. If you want, you write, we know that. One moment, please let me write this. Adjoint of K into A is equals K to the power n minus 1 into adjoint A. You can take determinant on both sides, use the properties of determinant and get the final result. Am I clear? So this proof I am leaving to you only. Try at home, please. Can I scroll up? Can I scroll up? This proof you try at home. For this one, take determinant on both sides and proceed. So like this is an important one. They might be keeping adjoint 2 times, 3 times. Important in finding determinant, not exact same one. Clear? So like here I am trying to plant a seed. How we are proceeding this one? Please listen carefully. Let us recall the property number 1. From the property number 1, we can write that matrix A into adjoint matrix is equals adjoint matrix into matrix A is equals determinant of A into identity matrix of order. So like for everything, this is the origin. From here only we are deriving everything. Like we are like let us replace A with, in previous case, we need adjoint Ka, we replaced with Ka. So here we need adjoint of A. So replace A with adjoint of A. Only one part you take like this one and equality one. Don't write entire thing. We can say that this is adjoint of A into adjoint of A equals to determinant of adjoint of A into identity matrix of order n. Right? So like this determinant value we will calculate. That will be equals to determinant of A to the power n minus 1 into in. So like same thing you write. Just doing next pre-multiply with A on both sides. So the pre-multiplying thing I am picking in such a way that I am having, or I should use this theorem. I have adjoint A. If I pre-multiply with A, I am having determinant A identity. So A into adjoint A into adjoint of adjoint A equals to determinant of A to the power n minus 1 into matrix E. Right? Using the associative nature of matrix multiplication, A into adjoint of A into adjoint of A is equals determinant of A to the power n minus 1 into matrix E. So what is this? Determinant of A into identity matrix. You multiply identity, you will get same only. This is determinant of A into adjoint of A. So we have determinant of A to the power n minus 1 into matrix A. So cancel determinant on both sides. We have what? Adjoint of A is equals determinant of A to the power n minus 2 into matrix A. So special case, as we wrote earlier, you can take n is equals to 2. Adjoint of A will be equals to A itself for a second order matrix. Clear? For third order, you will get determinant of A into matrix A. Am I clear? Any doubt in this? Anybody? Any doubt in this part? Now we are entering into the important thing. The value of this determinant. Here I have taken 2. In JE they will take 3, they will take 4, they will take 5, they will take some 2026. That is the year we are writing. Clear? So like using this pattern we will write for remaining all. Like here I have just taken the plane. If they want, what they'll do is like they'll put 3 in between, they'll put 4 in between, they'll put 5 in between, and they'll put adjoint and into something there, A inverse there. Like if you want to see, I can show you there is A problem here I kept. 61 you can see, no, what they did, like there is a determinant. 3 inside adjoint, 2 inside adjoint, det A into A. Clear? This is how they'll give in JE. If you want to do well in this, you should know all properties of determinant and adjoint. This is the next property, right? So like in this previous one, what we are doing, we are finding determinant. Maybe this one I'll prove here. We know that adjoint of A is equals determinant of A to the power n minus 2 into matrix A. So like det on both sides, taking determinant of adjoint of A is equals determinant of A to the power n minus 2 into matrix A. Property number 1, this is a scalar. Taking out, we should write power n. So this will be determinant of A to the power n minus 2 whole power n into determinant of A. So this will be equals to determinant of A to the power n square minus 2n into determinant of A. This is determinant of A to the power n square minus 2n plus 1. Base is same, adding powers. Now we can write this is det A to the power n minus 1 whole square. If you are doing 3 times, you will write n minus 1 whole cube. 4 times n minus 1 whole power 4 r times n minus 1 whole power r. N is your order. Maybe special case, we can write here this side. In special case, if n is equals to 2, right, we can write then determinant of adjoint of A will be equals to 2 minus 1 is 1 only, that A you will get. Like I think how many times you write adjoint for order 2 matrix, you will get determinant of A only. For order 3 matrix, if n is equals to 3, then determinant of adjoint of A will be equals to det A to the power 3 minus 1 whole square. 3 minus 1 is 2, 2 square will be 4, you will get det A to the power 4. So there is a problem. Copy this. Problem number 50 from the book. Open the book. Try yourself once.
Sir, could you explain the second step alone?
Right? So we'll tell we should use, everybody copied, right? We should
Sir.
use a property here. This problem is not only determinant problem, it is about properties of logarithms as well. Change of base in a log, you will be knowing, right? So if anybody don't know which properties we should use, let me write the 2 properties we are using in this problem. One is log A base B into log b base a must be equals to 1 given that a comma b are greater than 0 and a comma b is not equals to 1, right? So this is the first thing we will use, change of base theorem in logarithms. Second is like uh, log a base b into log b base c into log c base a must be 1, a comma b comma c greater than 0, neither a nor b nor c equals to 1. These two properties I will use. Tell me how much is the determinant in this case, if you can. So like I'm calling some names. If your name is there, please do respond. Ajay, Jose, Andrews, absent. Arun Bharati, KA, absent. Jagadish VR, absent. Jeevataran, absent. Ajay Khanna went to weekend. Shabarish Veeranan, Gautaman, Tanish. Yesterday he was here, but today is not here. He is that brave student, no, doing maths in chemistry class. Are we done? So who will tell? Srinivas, Venkatesh, Sai Nitin, Mithun. Calculations going on. Anybody from online? Shiv Ganesh
Sir, doing, sir.
doing. Shiv Kumar. Not there. Hey. 7 seems incorrect. 2. Like 2, you we have 2 power something. There is no 7 power something. Right? So like 2 is correct, then you proceed, use the properties and proceed here. For the students who was not able to solve this problem, the determinant I am speaking, determinant of A is equals to, I am expanding using row 1, nothing much, 1 into 2 3s are 6 minus log z base y into log y base z. Am I clear? Right, next. Minus 1 into log y base x into 3 times of log x base y minus log z base y into log x base z. Next, last one, plus log z base x into log x base y log y base z minus 2 times of log x base z. Right? Listen to me carefully. 1 into 6 minus 1 we get. This I can write log z by log y. Log y by log z will get cancelled. 1 you will get. Now, if you are multiplying this one alone inside, you will get again minus 1 into 3 times of. If you multiply inside, same thing. Bases are interchange, you will get 1 again. 3 minus 1 next. Like the second property I am applying, if I am multiplying inside, you will have y and x, z and y, x and z. Right? Numerator you will get is log x, log y, log z. Denominator again log x, log y, log z. Everything will get cancelled. Am I clear? You guys need more explanation in this. Right? So like next we will be having plus 1 minus 2 we will be having. So this is 5 minus 2 and we have minus 1 over here. This is 2. Like this is the task number 1 or checkpoint number 1 we did here. Like next, this determinant we need. What is that? We need to calculate determinant of adjoint of a square. Whatever it is, a square or a, it is a matrix for sure. Using that one, it is an order 3 one again. Square I do, I'll get same order matrix only. Order won't be square again. I will write here determinant of, right? What we do? Determinant of a square to the power 3 minus 1 whole square. So this is determinant of a square to the power 2 square, that is 4. So this is determinant of a to the power 8. Determinant of a to the power 8 is 2 to the power 8. Any doubt? Anybody? Any doubt? Anybody? Like, so this is in general. So hereafter, if you observe, I didn't give any proofs. I just wrote in general. When you have, maybe like, let me add 3 times situation here. There is some space. Determinant of adjoint of adjoint of adjoint of a 3 times is equals, this is determinant of a to the power n minus 1 whole cube. We can prove, but little complicated. Here you are writing r times. You can copy, these are all properties. Next, like I wrote here everything I can prove. Transpose I can move inside, inverse also I can move inside, outside. This is law of reversal. We learnt in trace, we learnt in transpose, we will be having in inverse, we'll be having in adjoint as well. Law of reversal I wrote in general again. Clear? These are all the properties. In next class we will solve the problems. Right? So maybe next class I will bring a set of around 15 problems which was not there in our book, but important models on this concepts. Clear? I will post in the teams, you consider as work. Maybe next Tuesday I'll post it. Next Tuesday, like extra problems. Maybe different book, different exams they asked, that one. In our book we have 2 or 3 only, not more. Clear? Any doubts? Anybody in today's class? Online, offline? I'll scroll up. I think everybody copied the 3 times thing. In general, don't write this. This we will do in next class. What? Determinant of E at least they have given a. That also they didn't give. Super. It is like people add that no sauce no in noodles, like that they add it. Whatever they want. Sauce. Take some cauliflower, cabbage. We'll see this one in next class. Right?
Sir, could you scroll up?
Yes, dear. So now attendance. First I am talking with offline online students. Please don't leave my class. Stay in class. Only leave after I marked you present. So in offline I am calling the names. Ajit V. Pack your bag. You can go home. Akhilesh S. If doubts is there, you can stay back or you can go home. Hari Krishna Night. My book, please. Please bring the book day after tomorrow. Harish M. You came from weekend to weekday. Harish Kumar S. Oh, you also came, huh? Only he came. J. Saravanan, please. I think Loga Prasanna Ganapati. How are you? Long time for see. Online. You can also go. Mithunes, please do write the practice test which is coming on Saturday. Plan, write on one day. Maybe if you cannot write 6 hours exam, it is advanced pattern. 3 hours you write on Saturday, 3 hours you write on Sunday. Maybe Sunday 3 hours or Monday. Mohammed Saifuddin Amin. Muttuvel. Naresh Balachandran. Did I call your name? Let them go. Sai Nitin. Give some space, please. Let Sai Nitin go home. Santosh M. Shiva Santosh. Sri Hariharan. Srinivasa. Venkatesha. Yoga Srivastwan. This much only. Anybody name I didn't call? What's your name? Krishna. Oh, I called. Anybody name I didn't call here? No. We can go. No, his name I called. Thank you, sir. Thank you, dear. Thank you. I'll tell you on Friday about that class. Thank you, sir. Thank you. So, my dear online students, now your turn. Afa, I can see.
Present, sir.
Present, I am marking. Then Aditya and Aris is not there, marking absent. Hariharan J. Marking
Present.
absent. Okay.
Present, sir. Present, sir.
Okay. Harivarshan is not there, absent. Jivi is present. Joshia Moses is there. Kirti Sri. No response. Will mark absent. Muthu Selvam. Present, right? Present. Nakshatra SS.
Present, sir.
Marked present. Padma Vinita.
Lesson, sir.
Marked present. Pranav Lakshman MG. Not there, right? Ritika T.
Present, sir.
Marked present. Roslyn.
Present, sir.
Marked present. Santoshini.
Present, sir.
Marked present. Then Shiva Ganesham.
Present, sir.
Shivakumar TS. Srinikesh. Sushant.
Present, sir.
Okay, marked present. Tarun Krishna. Tushya Balaganesh.
Present, sir.
Then Vasumati. Not there. Where count is going? Vinota R.
Present, sir.
Marked present.
It's actually Vasu.
Huh?
It's actually Vasu.
Oh, Vasumati, yeah, not Vasumati.
It must be.
Okay, like Janita, I marked you present. Remaining guys can leave. Thank you for attending my class. Tell me, dear.
Sir,
Thank
you.
you,
Sir,
Thank
I
you,
have a
dear.
doubt in one of the derivations.
You have the doubt in the derivation. Which one, dear?
Sir, in determinant of adjoint to adjacent, sir.
Determinant of adjoint matrix.
So could you scroll down
Here.
actually?
This
No,
one
sir.
only, yeah?
determinant of adj into adj, that is determinant of a to the power n minus 1 the whole square.
Okay. Give me a moment. This one.
Yes, sir. In that, could you explain the second step?
This one. Taking data on both side.
After that, the second one.
Like second one, you can see no determinant of a to the power n minus 2. Close the door. That is a scalar. Taking scalar out from a determinant, we should write scalar to the power n there. So like, let me write the property. Determinant of k into matrix A will be equals to k to the power n into determinant of A when k is a scalar.
Okay, sir. Thank you. I got it.
Okay then.
Yes, that's all.
Remaining guys, don't want to go home, huh? Want to be in maths class. Most only these guys are not there. Device only attending.
Yes.